Welcome to part 4 of our talks on Multicast. I originally called this Tech Talk Tuesday. This was a Tuesday evening broadcast. Work changed, so Tuesdays ended up not being a great night. I like the name. I may get back to Tuesday nights if things rearrange themselves a little. But the key part is for the pandemic, we're doing this every day, weekday. I want to give you a reason to get out of bed. I want to give you something to think about every day. If you want some supplementary material, some great things to get into, certainly you could read the RFCs. The RFCs will give you the real foundational piece and follow them, right? So start with the first one I mentioned, which was 966, and follow it out. See the evolution of the different things. You're going to see the RFCs for the different IGMPs and see what replaced it, what changed. Those are a great foundation when you do things like CCIE. Having read things like the RFC docs can be really useful for those nitpicky questions. Sorry, Cisco, but it's true. The nitpicky questions they really want to make sure you understand, so they're going to ask you a question that really has you looking at the RFCs. Cisco's also got 2 good books, Multicast Volume 1, Volume 2, and both, I believe, are available through Safari Online. If you're not endorsement, yeah, this is my endorsement. Safari Online's great. I remember the days when you bought O'Reilly books because they were the best. They were some of the best on, particularly if you're doing a lot of Unix. And the new version came out, and you're like, oh, I want the new version. And then you ended up with a metric ton of tech books, right? Every time you change jobs, when we were working more in, in consistent cubicles, you were packing all that stuff up, and, it was 3 or 4 cartons of tech books every time, right? With Safari Online, they're available to me. And that whole library, an extensive library is available to me. So if I read like the Cisco's Multicast Volume 1, I may not refer to it again for months or years, maybe. So it's not like I need to have that well-thumbed. Certainly if you need a well-thumbed reference, buy the paper. You can have the paper electronic, I love books, but you don't have to with Safari Online. So those are some additional resources for you. Let's get into the meat of this thing. And I called it turning networking on its head just because that whole process, essentially it's this conversation that happens, it's one directional, and the sender is not at all aware of the receivers are at all. And we don't see that in any other kind of conversation. You think about even a traditional UDP stream. If I'm doing like SNMP traps, I do care where the receiver is. I put it in an IP for network management station, trap collector, some device, and that each hop along the way, it darn well needs to know where that is. And they will, even if it's just a default route. But multicast is very different, as you've seen already from the prior sections. If you're just joining us, feel free to go back to my YouTube channel and check out the other sessions. There's some material beyond this that's done about more than a year ago, if I recall correctly. I'm replacing that content. I've been making some improvements. There's some things I said originally in those that I'm not particularly proud of, actually. So that's what we're doing now. Sort of my background, this is about certs, right? The other piece it's important to use to say that for at least the last 5 years, I've been designing, building, and supporting multicast networks, enterprise networks, cross WANs. So the fact that, it says I understand wireless design and enterprise design and I'm a design professional and blah, 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 only means so much. I know CCIEs that they're kind of bowing to my multicast knowledge because it's something that we don't all have experience with, and sometimes we just essentially got it to work mostly and then kind of left it alone. So for some disclaimers, Cisco's not paying me. It was, Safari's not paying me, not giving me any discounts because of this. And this isn't coming from my employer or any client, past or present. Now, obviously, that experience, yes, fuels this. Training that I've done while I work for a company on my own, all have combined to present this material. And I did an early version of this for a prior company. It looked very different, and it was a lot focused on their process. And if I were to do this for another company, I'm for hire for that I would tailor more to their process. Right? At this point, not so much. This fundamentals are really important. And then I try and say, I'm going to be really clear what experience I've had with something. With the majority of this so far, I've had a lot of experience. I really understand it pretty well. Where I get into things like bidirectional PIM, that's where I'm going to say, haven't done it. I know a little bit about it. And IPv6, I haven't done it outside of labs so far. I'm working in healthcare right now. Most of my clients are in that space. So they're hesitant to move forward right now on IPv6. They haven't had a compelling reason, and they have gear on a variety of ages, so it gets kind of interesting. Multicast is group communication, where a group is 0 or more computers. It could be 0. Originally defined in RFC 966 in 1985. It was quickly replaced. This was sort of a magical thinking sort of thing, a thought exercise, and as they got better, they became more practical, more focused, more like the product that you see in front of you now. And what are you going to focus on? This is now the problem I introduced yesterday. So yesterday we talked about PIM, the last 2 sessions, talking about PIM, protocol independent multicast. And there was this magic of like, okay, so there's a sender and a receiver, and the receiver starts doing joins toward the sender, but how did they know that sender existed? How did they know what his IP was? Or whatever. And so this is what we're going to work on today. How do I do that? How do I connect them? Just remember, when they come at you and they say, I need this done in 1/10 the time, which they're doing right now on some of these projects, get me some money or tell me what I can jettison so I can get it done in that time frame. I keep focusing on the time thing. Right now it's a time crunch. Certainly too, we're going to see, I'm pretty sure we're going to see a lot of budget super tight, right? We haven't had a lot of revenue, but we're trying to keep the doors open. So, I'm going to need to spread this out longer, or we're not going to get the Jumbotron solution. We're going to do a lot simpler. Right now we're putting up a hand scoreboard rather than a Jumbotron, because right now we have the budget for the hand scoreboard, but we're going to run conduits in that while we're at it. So when we need to put up a Jumbotron, we'll have all the cable runs we need to make it happen, right? That's how we're going to do in these times of trouble. And then, always double checking to make sure I'm off mute. Unicast versus multicast. This is one of the things I from the beginning I thought was one of the most important concepts to really get a hold on. If you put the sender out on the left-hand side of either of these, you're going to see that with unicast, I got to create a new stream for each receiver, but I don't do it with multicast. I send one copy down any particular link where there are receivers downstream. And so no matter how many receivers, it could be 1, it could be dozens. If it's 0 is the only time, no traffic. For 0, no traffic, everything else 1. So it's very binary. And why that's important, one respect, you look at it this way, this is the burden on bandwidth, but also from the host perspective, that not only is he having to use more and more bandwidth, but also particularly if they're TCP sessions, I need to keep track of session. I need to keep track of all those sessions, right? What was the last act? Well, that just there's a fair amount of overhead that's going to build. This one, I send UDP packets, boom, 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 out to the router. Router does what it's got to do. And then keeping you really focused on this, this is the range of destination addresses for multicast. And referring you back to IANA, so you can go in if you start doing some packet tracing, some sniffing, or otherwise analysis like NetFlow, you can start to figure out, at least for some of these lower addresses where they're registered, you can actually figure out this is what's running. This is what that traffic is. And then you can start to make decisions like, oh, why do I have OSPF? Where's that coming from? And start to do things like track that down and like, oh, we turned on OSPF on a device. I didn't want OSPF. We're running EIGRP or ISIS, right? So there's a lot you can do with multicast. But remember, never a source. Never, 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 right? IGMP, that was at layer 2. That's how hosts are telling the router, I want traffic for this group. And then we had 3 versions, 2 for IPv6. There are your dates. There's the RFC numbers. They even put in a link if you know. And the difference between multicast and unicast, for unicast for sure, that destination IP indicates where the packet's going, period, end of story, right? We can have these anycast addresses, if you've ever run into that, where the idea with an anycast address, it's probably a /32. I can stick it all over the place and advertise it because it's some critical function. It could be DNS. You think about the Google DNS 8888 and 8844. Well, if those went to one or two devices or 2 clusters located in one part of the world, it's pretty inefficient. Because then I've got to crawl. So if I'm trying to use that, I'm trying to crawl from all over the place and get to one location. That I can use Anycast and stick these unicast addresses out all over and advertise that range of the 88 range, and it's going to appear in multiple places, and I'm going to end up at the optimal route from my location. Since it'll be internet, it'll be BGP, and so my provider may be pushing me towards some particular set of nodes that are most convenient for it. And my first line provider is going to be doing things like, hey, there's a route out through this peering point, and that's got problems right now. I've got other routes that are less desirable, and I'm going to push you out through a different peer to get there, right? So, but multicast, that's not true. Multicast exists anywhere, everywhere, or nowhere. So the sender broadcasts with no idea where the receivers are, or if there are any at all. The general idea is something like a video stream, like something like what I'm doing right now. It's doing it. People can tap into it, right? I can music, video, whatever, right? I can just do it, and those that want to pick up. Think about it like radio, right? And the commercial radio, AM, FM, even really satellite, right? The Sirius and all that they're broadcasting, right? In the end, they care about listenership, and they need, for some things like with broadcast radio, they need to kind of figure out what their impact is so they can sell advertising, but they don't care. They have no idea, right? Receiver needs to be connected to the sender. So, yeah, it seems pretty obvious. And PIM joins follow the unicast routing. That's how you get a path between a sender and a receiver. And these distribution trees are what are forwarding packets. And I said they were built dynamically. So the idea is if something happens to your network, this isn't set in stone. Now I can have set in stone. There is static routing inside multicast, and we'll talk about that in a future segment. So that obviously is more difficult to rebuild dynamically. Reverse path forwarding, we mentioned this already. We mentioned this in a prior section. We're basically trying to make sure that a couple things. We're making sure the interface as traffic's coming on is valid for that. If it's sending traffic, it's valid that it came from that interface. That's where I expect to get it. If it comes from somewhere else, it's likely a loop. We're going to drop it. And that using the unicast route table. I mentioned in the last slide, there is static routing. So in some cases, for example, if your provider isn't supporting multicast, you're doing a layer 3 connection between sites and you're not supporting multicast, I can do a GRE tunnel and push the traffic through the tunnel, but I have to do some static routing for multicast specifically to tell it to use the tunnel and not to try and go the unicast path. And we'll get into more details on that in a future section. And this source really isn't trying to get the receiver. It sort of is, and we'll go over what that is. Mostly the receiver is really trying hard to get to the source. And I said that shortest path source from the unicast routing table. So in this case, particularly if it's a protocol like RIP, that's obvious, less hops. It's the last hop router is doing joins back to the first hop router, and then the traffic's flowing the opposite direction. So these PIM joins going one way, traffic's going back another. That's not true in dense mode though. So the joins in dense mode, with dense mode, what I'd be doing is that this first router would flood both links. They'd flood down. Eventually this guy would get the joins both directions. And in that case, if he wanted the traffic, he would prune the second link. He would not be forwarding that out this link since he already had a join coming down. Now he might have if for some reason this direction got slowed up somehow. He might have already started to forward that direction. And from that information, it could figure out what the best path is and then prune out what it doesn't want. For these routers with dense mode or sparse dense where there's no rendezvous point, they're going to, since they have no receivers that want the traffic, they would send prunes back. Now it needs to start, this link here needs to prune first, because then he's sure that, nope, nobody, these are my only links, these two are my only links, nope, I got the join coming in this way, coming down from the sender from the other direction from the receiving side, that they've now sent a prune saying they're not interested in the traffic. I have no other interfaces that are interested in the traffic. I would then send a prune up to this guy. Then he, having no other interfaces that are interested in the traffic, would then prune back to the first hop router. So that's how dense mode works. It has to go and flood this entire network, and then everyone has to go, yeah, no one wants this. And then it'll reflood on a periodic basis because it wants to make sure, like, hey, no one's decided that they need that traffic, right? I got a sender. Do you want this? And then I mentioned this was a very important point. I like to emphasize this a lot when you have equal cost paths. So with RIP, this is obviously equal cost, and it could be with the other protocols like OSPF or EIGRP. If say it's a LAN, these are a bunch of 10 gig links, they look the same. And of course, with default values, the OSPF, remember that's always a test question, either CCNP, CCIE. These can be 100 meg links, and if we use default values for OSPF, that these, I could have a 10 gig here and a 1 gig, and these are 200 megs. They look the same, right? Because the reference bandwidth, right? The unicast wants to do load balancing. We're going to try and do PIM joins up through a single route, unless you enter this multipath command. And the multipath is allowing the traffic to come in. So really from this guy, when he's doing his check on that traffic, you can see, yeah, that's a valid route and that's a valid route. I can take either of those. he shouldn't see a join coming from the interface with the sender. So he still should reject that, because that isn't a valid route back to this last hop router. That he should drop. And the multipath command, I think there's a slight bit of risk. Reviewing it from what I've said before, I think there's a slight bit of risk of looping that, however, in a lot of modern designs with, a data center, I may have like distribution switches that are not Nexus, so they're not doing VPC, and they're not in a VSS. So it's perfectly valid to have these equal cost layer 3 paths, and I want to make sure that if a stream is directed through one route, through one segment, then I want to make sure that it doesn't get dropped. Otherwise, I'm going to have multicast becomes unreliable. How are we doing on time? We've used a lot of time with review. That's fine, though. We'll get into the meat of this tomorrow, really. And so I went through this. This is how you create a shared tree. There's an RP. Still haven't told you how you find the RP. This guy IGB report. This guy does a PIM join. He does a PIM join back to that RP with this star comma G, saying, "Hey, I've got a list this last hop router saying I have a listener that is interested in this group. Got anything for me?" That's really what he's asking. He's asking the RP, "Got anything?" At this layer, if it's a, say, a multi-layer switch with a lot of SCIs, that star comma G, even without an RP, as long as multicast routing is turned on, that different segments may have multicast traffic, and they can route between them. So that star comma G, if you look at the M route on that last hop router, he's going to say this interface is interested in that traffic. If he has other interfaces and they have senders, and say they're just directly connected, it's a big 40 or 9410, something like that, and it's got a bunch of user blades on it, and I've got a sender whatever starts broadcasting, and on a different VLAN I have a receiver that can connect. Multicast routing is turned off, they're not going, they shouldn't connect. If they're on the same VLAN, they will, but you need to turn on multicast routing. Those are some important things I want to keep emphasizing. Now, how does the RP know about senders? Well, the first hop router is doing a register. The register is a unicast, so I depicted here it's kind of a Hail Mary. So he's actually bundling up this multicast traffic, encapsulating in the unicast. He's got to know the IP of the RP, the internet protocol address of the rendezvous point. He's going to do that. So right away, this RP knows about that traffic, and there's going to be some benefits to it to the receivers. And the RP is actually going to start doing joins on its optimal path back to this first hop router. So the joins are going this way, and the source traffic is going to go this way. And that's the simple of it. Now, as these joins happen, there's going to be a point where once this join completes, there's now a multicast path through here and also through here. So you will have duplication. I mentioned that as one of the problems of multicast. There will be duplicate packets. This guy has to then send a notification back to the first hop router and say, you can kill the registration tunnel. Don't need it. And there's some other situations where he'll actually prune out this traffic temporarily. It'll idle out that traffic if he has no receivers. If he has no reason to keep that traffic, but he's going to keep in touch with the router. He wants to be able to reconnect instantly if he needs to. So this on the RP now creates in its M route an S comma G, S being a unicast address and G being the multicast group address, a class D. This will be ABC and that'll be D in its M route. And it'll show the incoming interface will point back to this first hop router, whatever the unicast best path to that first hop router. And the outgoing, well, if he's already learned about receivers that are interested in that group, that star comma G I mentioned just a second ago, that he can then start forwarding the traffic. And he can do another unicast Hail Mary out to this last hop router to go, hey guys, here's some traffic, right? And then we'll see what happens from there. So you see this register stop. I mentioned that already. That's the the traffic's coming. We're good. I got it. That it's happening through multicast. This doesn't need to do this unicast anymore. I got you. I have this traffic. Source flow on source path to the RP, and then the traffic flows now flowing from the RP to the receivers. Now there are some like bidirectional. Everything runs to the RP, so we kind of stop at this point for bidirectional. That it all flows through there, and the idea with bidirectional is I could have some sort of reverse and back. If that topology demanded it, I could do that, but normally I couldn't. Now, since this, and I simplified the drawing a little, since this now last hop router has learned about the source with a particular unicast address, it's now looking in its unicast table and saying, I got a better route. This is not the most efficient route. It could be. If it was the router on the far right, that would be the most efficient path. Going around this way would not make a lot of sense, unless, of course, this was a T1 and these were 10 gigs, right? And you're running a routing protocol that knows the difference. So I'm going to do a join back this way, and now that source traffic is coming directly to the last hop. So in this case, one hop away, first hop, last hop. And then I'm going to prune back the traffic from the RP. I don't need them to forward anymore. But of course, since I did this join, I'm now getting duplicates. And I said that was a problem with multicast. Duplicates appear in a number of cases, and that's because we're switching over from a strictly unicast in the case of this last join here, and actually in both cases. So a unicast registration of the RP is going to get duplicates when the multicast PIM joins finally all make the connection. And in this case, I had a multicast stream coming directly from the RP, and now that I've got a shortest path tree, I've switched over from the shared tree, which is the going to the RP, and I go to the source tree directly. That I'm going to get duplicates before I can now say, got it. The new line is in. I'm going to cut you off. And the prune traffic, you'll actually see the prune traffic in your MRoutes. So if I went onto this RP and I did show IP MRoute, you're going to see this P flag showing up on the entries, because it's saying that I no longer need to send traffic down this link, but I do remember that there were interested hosts down there. And it may be relevant again with that star comma G. It could become relevant again if a new sender pops up. So if a sender pops up over on this side, he does his registration to this RP, and the RP goes, I got new traffic. For that group, and it may send it down, it should send it down to this router, and if then it's going to forward it on the receiver, and in that case it's not much is going to change because the RP is in the direct path. Enterprise RPs are often not in any path. We'll actually set them off to the side because we want them to focus on just dealing with connecting this traffic and not have to have a load actually routing normal unicast traffic. How are we doing on time? We're almost, and I've already kind of gone through this sender switch off. And now that I don't need it anymore, I've got the prune back. I no longer have any traffic that immediately wants this. I'm going to prune this traffic back. But there is some keep alive traffic that's happening between the RP and the source. Because he needs to know that that guy's still around. That he needs to know that this source is still around. in case anybody new pops up, like this guy pops up with a receiver, they go, oh yeah, I got a guy, and he can go and quickly bring that back up, forward the traffic, and bring this guy online. And we'll pick up with Any Source Multicast tomorrow. Thanks for joining. If this is your first one, hey, welcome. If you've been following, bless you. Stay with. Ask questions. If you post on any of the social media sources I've been posting this stuff, you ask questions, I'll get notified, and I'll try and answer your questions as quickly as I can. If it's a short answer, great. If you want to engage on long, complicated answers, that we can make that work if we need to. So thanks again, and I will see you tomorrow, same time. Same link. Keep using that same link.